Hello, and welcome to the CIBSE Journal CPD module number 258, the optimisation of substations and consumer systems in the new Heat Network Technical Assurance Scheme. This module explores how the new HNTAS aims to ensure new and existing heat networks achieve minimal levels of performance and reliability. This module is sponsored by NIBE. The UK government has an ambition for 20% of the nation's heat to be provided from heat networks by 2050, up from 3% in 2024, as part of the nation's transition to net zero by 2050. Heat networks distribute heat or cooling from centralised sources to a variety of different customers, such as public buildings, shops, offices, hospitals, and homes. Whether supplying a few neighbouring buildings or entire cities, these centralised systems remove the need for individual boilers or heaters in each building connected. A major appeal of heat networks is that they can take advantage of a wide array of different heat sources, including the recovery of low-carbon heat from sources such as industry and data centres that would otherwise be wasted, along with naturally occurring sources such as geothermal or rivers. While the government's heat ambition is admirable, the problem is that many existing heat networks are, according to research, operating suboptimally, to the detriment of customers, particularly where networks operate at lower efficiencies and increasing fuel costs are passed through. To support the delivery of net zero and ensure a more efficient energy system, the government introduced the Energy Act, which became law in 2023. This included powers for government to mandate heat network technical standards in Great Britain through regulations. These regulatory technical requirements for heat networks are expected to be introduced in forthcoming regulation. In advance of this, the government will be publishing a mandatory Heat Network Technical Assurance Scheme, or HNTAS, which aims to ensure new and existing heat networks achieve minimum levels of performance and reliability. It is aimed at parties engaged in planning, construction, management, operations, and maintenance of heat networks. The HNTAS documentation, written by specialist energy consultant Fairheat, will be phased in over time to ensure the sector has sufficient time to shape, understand, and comply with the scheme. The first tranche of these documents has been published in draft form. There are overview documents covering the new building technical specifications and assessment procedures for the 6 major elements of a heat network: the energy centre, distribution network, substation, communal distribution network, consumer connection, and consumer heat system. This CPD sets out to describe the new HNTAS scheme and outline how, in particular, it is expected to work for heat interface unit, HIUs, and substations. The need for change. A fundamental change to the regulatory landscape is required for heat networks to achieve their decarbonisation potential. This is driven by the need for enhanced consumer protection, as customers connected to a heat network are obligated to use a single heat provider, contrasting sharply with the competitive market available to those using independent heat sources, such as heat pumps or gas boilers. The new regulatory framework mandates reliable heat and hot water supply at fair prices, a core measure the government anticipates will boost heat networks' appeal and drive market expansion. The mandatory HNTAS scheme is intended to ensure heat networks achieve minimal levels of performance. The government also expects that in a regulated sector where standards are harmonised, heat networks will become a more attractive investment proposition for asset managers. Energy regulator Ofgem will be responsible for regulating the sector and monitoring heat networks' compliance with the regulatory framework. Its role will include managing the authorisation regime, ensuring compliance with consumer protections, and managing audits and enforcement activity where necessary. Performance-based assurance. HNTAS is a performance-based assurance scheme. For each element, assessments against minimum standards are made at various life cycle stages of a heat network. For example, in the design and construction stages, Assessments will be made to validate the claims that certain performance outcomes will be achieved. Similarly, on commissioning, assessments will verify that performance outcomes have been achieved and maintained. For new networks, an assessment pass will be required at 3 key gateway points in a heat network's life cycle before a network is allowed to start design, before starting construction, and before starting operation. An assessment pass will also be required after 2 years of operation to ensure that performance levels continue to meet the requirements. Technical requirements. The first HNTAS technical specification documents detail the technical requirements to be met for the 6 elements of a heat network. Outline performance monitoring requirements, detail key failures to be avoided at each stage, and evidence requirements to be provided to demonstrate conformity with HNTAS and avoidance of key failures. All technical requirements are derived from existing industry documentation. The primary reference is the CIBSE Code of Practice CP1 2020, which provides the foundational technical standards for the regulations. For topics not covered by existing industry documentation, additional technical requirements have been added to address these gaps. A new Heat Network Technical Standard, or HNTS, is being developed and will be published later this year. This will supersede CP1 and will be used as the predominant technical standard referenced in HNTAS, KPIs or key performance indicators. The HNTAS technical specification overview document contains KPIs to be achieved and maintained in operation for each element of a network. These build upon the and formalize the KPI concepts outlined in CP1 2020. While both documents emphasize the importance of performance monitoring, the HNTAS draft provides a more prescriptive and detailed framework for KPIs. The KPIs are split into 2 types. Assessed KPIs. These are KPIs that are assessed against predetermined targets at commissioning and throughout the operation and maintenance phase in order to achieve and maintain HNTAS certification. Reported KPIs. These are KPIs that are not assessed against the predetermined target through the operation and maintenance phase, but still provide valuable information, so are to be reported in the same format. As an example, the draft overview technical specification document for consumer connection HNTAS TS-CC P0 lists 13 assessed KPIs. KPI 1 relates to the Automatic Remote Monitoring System, or ARMS, ARMS, connectivity. It explicitly measures ARMS connectivity and data completeness, with a set of percentage targets given at the commissioning stage, i.e. 100% connectivity, and the operation and maintenance stage, greater or equal to 99% connectivity. Assessment procedure. Alongside the HNTAS technical specification overview documents, the government has published 6 corresponding assessment procedure documents in draft form. Each document details the activities to be undertaken to provide assurance that the obligations in the corresponding technical specification document have been fulfilled. Further draft technical specifications and assessment procedures for new build networks and for existing networks will be published at a later date. In total, there will be 34 technical specification documents published and 34 corresponding assessment procedure documents. While a total of 68 documents may at first appear to be overwhelming, the documents are organized logically for each of the 6 elements, with subsequent documents corresponding to each phase of a heat network's development and operation for each element. In addition, there will be 5 supplementary specifications detailing the requirements for acceptance testing for the different elements. Final versions of all documents will be available once the scheme is live in 2026. The optimization of substations and consumer systems. With more than 50,000 heat interface units being installed each year in the UK, setting performance standards has become increasingly important in supporting the deployment of low-carbon heat networks. HRUs function as the critical interface between the heat distribution network and the consumer's heating system. The Engineering Services Association, or BESA, UK HRU test regime publication aligns closely with the objectives and specific technical requirements of the draft HNTAS, particularly concerning the performance of consumer connection elements, which typically include HRUs. The aim of the document is to introduce a pragmatic and practical way of testing and comparing HRUs to provide a basis for assessing performance for those developing and designing heat networks. The performance metrics defined in the BESA test standard align with the assessed KPIs set out in the draft HNTAS TSCC P0 for volume-weighted average return temperatures, VWAT, and standing heat losses. The performance of substations, too, is important in optimizing the performance of heat networks. The substation provides the connection between the district distribution network and the consumer distribution network. The document HNTAS TSSP0 specifies several KPIs to ensure a substation efficiently transfers heat and maintains predictable flow conditions. To assess these KPIs, substations must use a metering and monitoring system, which records data at least every 5 minutes for flow, temperature, and pressure points, and at least every 30 minutes for heat meters and water meters. The required substation monitoring points are set out in HNTAS TSSP0. Legacy systems. There are around 14,000 heat networks in the UK, but government-funded analysis over the past decade has revealed a myriad of issues affecting performance that risk undermining the government's goal of providing affordable, low-carbon heat. The most frequently are listed in the panel of 16 common reasons for failure of legacy heat networks. 16 common reasons for the failure of 16 common reasons for the failure of legacy heat networks. Number 1, insufficient consideration of heat network requirements at concept design stage. Number 2, incorrect sizing. Number 3, unnecessary complexity. Number 4, unsuitable hydraulic arrangement. Number 5, poor insulation specification and installation. Number 6, poor planning in civil works for underground pipework. Number 7, poor underground pipework installation. Number 8, insufficient monitoring and data collection. Number 9, inappropriate design and commissioning of consumer connection and/or heat system. Number 10, lack of consideration given to system pressures. Number 11, lack of consideration given to maintainability. Number 12, poor installation and commissioning practices. Number 13, inefficient control. Number 14, uncontrolled network flows. Number 15, high return temperatures. Number 16, poor water quality. Heat network customers are unable to shop around for alternative suppliers, and many, especially those using older and less efficient networks, may be paying more for their heating as a result. Under the HNTAS scheme, existing networks will have to meet yet to be published performance requirements. However, the government says that there will be a significant transition period to allow operators to ensure appropriate metering is in place and to be able to prove performance. It also says that the performance requirements for existing systems will be set at a more permissive level than those for new networks, and that operators will be given time to reach these. The Heat Networks Optimization Guide, published in 2023, is expected to be used as the basis for setting performance requirements for legacy systems. As such, it provides a standardized set of processes and approaches that anyone undertaking optimization can use, with the aim of providing a minimum quality standard. The guide recommends taking a 4-stage phased approach: understand, stabilize, easy wins, and continuous improvement. Once root causes have been understood, the stabilization of a heat network should take place to improve performance and reliability. Easy wins can then be carried out that have short payback times but require more planning and design. The continuous improvement cycle is designed to enhance performance over a long period. It has 4 repeating stages: measure, analyze, test, and implement. The guide outlines KPIs for quantitative analysis of heat network performance using data from the building management system, heat meters, and utility bills, which may form the basis of the HNTAS legacy system performance requirements. HNTAS certification. Once a new or existing heat network has passed all assessments, it will be awarded an HNTAS certificate as evidence of compliance. The heat network operator will be required to regularly submit data to an HNTAS digital portal to show that the heat network continues to meet the HNTAS KPIs. This should ensure that more heat networks run efficiently and help the technology support of the delivery of net zero. Copyright Andy Pearson, 2025. With the building services industry undergoing a paradigm shift as it strives to improve the energy efficiency of new and existing buildings and make them inherently safer, members of CIBSE need to focus their learning and development on key industry issues. Members of CIBSE and other professional bodies are required to maintain their professional competence throughout their careers. Please visit the link in the description should you wish to obtain a certificate to keep on your CPD record.